Hello, good people. We are going to be talking about interlocks or interlocking. To be specific, an electrical interlock. So, electrical interlocks is basically used where you need to prevent, let's say in this case, one coil from energizing whilst the other one is energized. So interlocks are basically used for safety reasons. In some cases, let's say if maybe you need one motor to be running whilst the other one is not, or you need one to run after a certain time, when after the other one has started. It's things like that. So whenever you need maybe say your motors to be running in sequences, so we make use of interlockings. You need to prevent, let's say for in a case of a forward reverse or automatic start delta, that is for safety reasons. You make sure that the motor now does not change while it was running in forward, and then all of a sudden you're changing the motor to be running in the reverse direction. One, there's going to be a short circuit in the main circuit, and also it wouldn't work even if say if we say there wasn't going to be a short circuit. Now you can't, while a motor is in speed running in the maybe say clockwise direction, and then there you are now, before even stopping it, you're starting also for it to run in the other direction. So now we're gonna look at that electrical interlocking, which is by means of auxiliary contacts of your contactor. So now you need to the circuit not to stop. Let's say maybe a certain motor, or you have two motors, you do not want the motor to stop while the other one is still running, or you need one to be able to, or not to run while the other one is running. All of those we use interlocks to do that. So in this case, I will show you how interlocking works. Let's say this is like an example where we have KM1 and KM2. So we want when KM1 is running, or is energized rather, and then KM2 must not be able to energize. Same thing, when KM2 is energized, then also KM1 must not be able to energize. So there we are switching on. So now that means one is running in this case. Okay, so let me just fix that because I see I have a stop button instead of a start button there. So we need to remove that because it is going to switch on. So we need a push button, which is a normally open instead of that one that is of a normally closed. There we go. So here again, if you have a look, we also have retainers. We also have holding contacts to make sure that the coil of KM1 remains energized even when you release your finger from the stop button. So there we go again. Yes, now the current is not passing through anywhere. It will only pass when the start button is pressed. So now I'm going to start with KM1. So now this means these are your interlocks. This is the interlocks. You see, these are your interlocks. That is the electrical interlock from KM2 normally closed and KM1 normally closed. So now press the start button. The S3, KM1 energizes. Do you see now, if KM1 is energized, KM1 opens there. Remember, with the operation of the contactor, when the coil energizes, the contacts are going to change their natural state or their normal state. That means the contacts that are normally open are going to close, and the contacts that are normally closed are going to open. So now that means 21, 22 is a normally closed, and therefore it will open. So here's another thing with the numbering or the labeling of contacts of your contactor. 1 and 2, they represent, which is the second number on the contacts, which is 1 and 2, 1 being the input and 2 being the output. They tell you that the contact is anomaly close. But the minute you see a 3 and a 4 as the second number, as you see right here, we have 13, 14, but the second numbers is 3 and 4. If you look at this one, it's 23, 24. That means you have a 2 and, you have a 3 and a 4. That represents, or that tells you that is anomaly. That is anomaly open. That is anomaly open, but you have a 1 and a 2 that is going to be anomaly closed. 1 and 3 is anomaly closed. Okay, so now that is standard. Then if you see a 1, 3, the first number, it tells you the position. It tells you the position of the contact. So that means it could be that is the first set of contacts if the first number is 1. If it's 2, then that means that is the second set of your contacts. If it's 3, that means it will be 30 something, or it will be 30. Let's say if it's 31, 32, that means that is the third set of the contacts. And then if it is the 3 and the 4, that means that is anomaly open. If it's 11, 12, that is the first set of anomaly open with that 1 and 2. I hope what I'm saying makes sense. So it is open. I was just trying to fix the holding contact for KM2. I made a mistake there. So now that means there it is, KM1 is open. So if we start 2, the current passes through up to 0.21. So it is not going to energize the KM2 coil. And then we're gonna press the stop button, it de-energizes. When we press that of S2, KM2 energizes. When KM2 energizes, KM2 on the other side, the auxiliary of this coil of KM2 opens, making sure that when you press the button of switch of S3, KM1 does not energize. So that is what we call interlocking. Now we have prevented those two coils from energizing at the same time. Thank you.